In the 20th century, the electricity industry has either been regulated or state-owned firms. In the United States, investor-owned utilities comprise the largest share of the industry, with fewer of them being state-owned firms of some form. Because of the economies of scale and scope created by large-scale generation, transmission, and distribution technologies, these investor-owned utilities evolved into local monopolies through a process of consolidation around the turn of the 19th to the 20th century. I discussed that process in a previous video, and here I'd like to discuss the design of regulatory institutions and how some of the most important technological changes in the 20th century have put pressure on those regulatory institutions. Utility regulation in the U.S. and natural monopoly theory developed somewhat at the same time. Natural monopoly theory developed a little later, so a lot of the early regulation was learning by doing. The first state public utility commissions were started in Wisconsin and New York in 1907, and many states followed suit. By the mid-1930s, most states had authorized a public utility commission using legislative statutes to define their regulatory missions. Economists use the natural monopoly model to think about the design of public utility regulation, and it's represented in the natural monopoly graph that we are looking at here. The declining long-run average cost curve represents the economies of scale that characterize these high fixed cost, low marginal cost firms. In a market with this demand curve, long-run average cost declines over the relevant range of demand, so a single firm is the least cost way to supply in this market. The monopoly outcome, where the single firm sets marginal revenue equal to marginal cost and then charges a high price, reflects the progressive era concern about the ability of the monopoly to exercise market power. In this market, the competitive equilibrium at price equals marginal cost is not sustainable because the high fixed costs mean that marginal cost is less than average cost at that quantity. So the firm earns a loss at that level of output when it's facing this demand curve. Between the undesirable monopoly outcome and the unsustainable competitive outcome is a regulatory sweet spot. Set the regulated price where price equals average cost, so the firm will earn its opportunity cost of capital on its assets. This theoretical framework has been the foundation of the regulatory institutions developed in the U.S., and they were largely developed in the first half of the 20th century and implemented through regulators determining the rate of return on capital that the firm could earn. Having determined that rate of return on capital, they then determined the revenue the firm can earn and the prices that firm could charge to residential, commercial, and industrial customers to earn that total revenue. Historically, these prices were at average cost and didn't vary over time, even though the cost of generating and delivering electricity does vary over the course of the day and seasonally. The pricing didn't reflect that. Over that earlier period, this model fit the technologies and cost structure of firms reasonably well because the technologies were large scale, economies of scale and scope were large, and the technologies were relatively stable. But by the late 1980s, technological change was reducing that fit between technology and regulatory institutions in electricity. The invention of the combined cycle gas turbine changed the scale, reduced the scale at which generation was economical. And this made the generation technology space and cost structures more heterogeneous compared to the more homogeneous set earlier in the century. This innovation provided an opportunity to apply institutional and organizational economics to analyze the effects of this technological change. And in particular, this allows us to apply some of the foundational ideas we find in Ronald Coase's work, The Nature of the Firm. One implication of Coase's original work is that vertical integration emerges as an organizational form in response to transaction costs in the vertical supply chain. From its origin in the 1880s, electricity firms were vertically integrated due to the transaction costs embedded in the very tightly integrated technology system from generation to transmission to distribution to retail. It was either costly or simply not feasible to unbundle those parts of the vertical supply chain into separate transactions by separate contracting firms. Another important piece of IOE literature that's relevant to this question is Klein, Crawford, and Alchin's 1978 work on vertical integration and contracting as organizational substitutes. If transactions costs change at the margin, then that changes the organizational structure in an industry that is the most economical or the most profitable to adopt, and that means that as transactions costs fall, that moving from vertical integration to contracting between independent firms is one implication of the reduction of transaction costs. We see that in electricity in the formation of wholesale power markets in the 1990s. Changes in generation technologies reduced economies of scale and scope and led to the formation of competitive wholesale power markets. In several states in the U.S., regulatory restructuring had to happen to allow for the vertical unbundling of these vertically integrated firms. And in fact, the restructuring required vertically integrated utilities to sell their generation assets to independent generators. These independent generators now compete in organized wholesale power markets. These wholesale power markets are operated by regional transmission organizations. And at this time, about 3/4 of the U.S. population lives in an area where the electricity that they consume is transacted through these competitive wholesale power markets. And right now, in the early 21st century, we're seeing a second type of technological change that's now changing the cost structure in this industry. We know that digital communication technologies have transformed our daily lives in many ways, and they have now begun to change the operation of the electricity grid, as well as to offer new and different entrepreneurial opportunities and customer value propositions around the edge of the electric power network, or around the distribution edge. And in particular, the name that's attached to this set of technological changes is smart grid. The idea with smart grid is that you have a set of digital communication technologies, a digital communication network that provides an overlay on the existing electromechanical electric power network and allows for more distributed intelligence, digital intelligence within the network. For example, now to have sensors and monitors that are digital within transformers and substations along power lines so that you can use those technologies to see what's actually happening and what the state of the network is at any point in time. Another important technology for giving consumers more opportunities is digital meters. And so digital meters allow for real-time monitoring and measurement of individual consumption of electricity and allow consumers to see their own consumption in real time and potentially to take actions and implement technologies to change their consumption. This set of consumer-facing digital technologies also very much enables what we call dynamic pricing. The idea that rather than pricing at average cost and having a fixed price throughout the day, month, year, you can have dynamic pricing where the price can change as conditions on the network change. If there's very high demand, you could see prices going up, and people respond to those prices by reducing their consumption. And that brings in that negative feedback loop that we know prices provide in markets to coordinate supply and demand when we have scarce resources. So the digital technologies that allow for very fast and real-time monitoring and metering and adjustment of consumption very much are the next wave of technological change that we are seeing in the electricity industry. And this is likely to bring along another set of transaction cost reducing changes in the organizational structure of firms in this regulated industry.